We will now continue with our discussion of various components, classes, interfaces, and so on in the Java Executor framework. And we're going to start talking about something called the Java ExecutorCompletionService. And you'll see how this is an interface plus some other classes and interfaces that defines a really interesting framework for handling the completion of async tasks. I should probably say the submission and handling of async tasks. That's probably a better way to put it. And then I'll also show you how you can instantiate an instance of the Java ExecutorCompletionService to use it in practice. So if you recall the Executor service that we looked at a week or so ago, and you think particularly about how we used it to implement our prime checker app, the way it worked is we called submit, which returns a future, and then we had to have another thread off to the side that sat there and synchronously blocked, waiting for the asynchronous computations to complete. And that was problematic because the order in which the operations complete, since they're running asynchronously, may or may not have anything to do with the order in which we have to synchronously wait for them to complete. And that means that as things complete, you don't find out about them necessarily right away. You find out about them whenever your background thread happens upon a future that has been completed, but other computations may have completed earlier, but we're stuck waiting for one that hasn't completed, and we have to wait until that one's done before we can learn about the ones that are finished. And that's what's called a synchronous future processing model. And it's deficient because you don't get to find out right away when something is done. You find out when you get to the point where you can ask it, are you done, by calling its get method. So another way to look at this is the get method here may block even if some other futures have already completed and we just haven't got around to asking if they're done yet. So that means that your program is not as responsive as we would like it to be. So the completion service, or the executor completion service, fixes this problem by using a so-called async future processing model. And that combines an executor with an internal blocking queue, and that internal blocking queue is used to store results that have completed, such that whenever we get an item off the queue, we already know it's finished, and so we can get its results right away. So it takes the guesswork out of which item has finished, because it doesn't show up in the queue until it's actually done. So what we're kind of doing is we're kind of moving the queue out of the application program, and we're moving it into the Executor Completion Service framework, and then we're only sticking things on the queue when they're actually done. So that's pretty cool. And we'll take a closer look at how this works shortly. It's got a lot of moving parts. At first, it seems very daunting and complicated, but once you kind of get the hang of it, it's really pretty cool and very simple to understand. The completion service interface decouples async task invocation or submission, invoking a task to run asynchronously, from the processing of the results of the task when the task is finished running, when it completes. And it's defined using this interface. And as you can see, the interface has a very simple set of APIs, or it's got a very simple API with just a few methods. It's got submit, take, poll, and basically two versions of poll. One that will wait for a certain amount of time, and one that just checks to see if it's got a result right away and returns null if not. The completion service interface is implemented for you using something called the Executor Completion Service class. And that class does the heavy lifting to give you one variant of a completion service. You could implement your own if you wanted to by implementing the completion service interface, but they give you one out of the box. And internally, the Executor Completion Service, as the name implies, uses an executor, which is going to have a pool of threads, and a blocking queue, which is what's used internally to queue up the results as they complete. And the executor runs the tasks that are submitted to it in this pool of threads. You can control what kind of executor you use. You could use a fixed size executor. You can use a cached executor, and so on and so forth. And the blocking queue is used to queue up the finished results so that some client thread or threads can come along and take or pull them to get them out as they finish. And then there's also something called a queuing future, which is a subclass of future task. We'll talk about future task shortly. And that's used to queue up a task when it's finished. So when the task is done, like a two-way task is done, the queuing future is used to queue this up in the blocking queue. You can use the completion service interface and, of course, by extension, the executor completion service class, which is what implements the framework, to implement the proactor pattern. And the proactor pattern is another POSA 2 pattern. I documented this pattern probably in 1996 or so, I think, and that showed up in the POSA 2 book. And basically what this pattern allows you to do is it supports the demultiplexing and dispatching of event handlers that are triggered by the completion of asynchronous events. And so what you typically do is you have a client thread that starts up some pool of threads, which then run an event loop. You submit work into this object. It goes ahead and runs things asynchronously. And then when the results complete, you can get the results somehow, typically through some kind of completion queue or completion port or whatnot. And that's basically what the proactor does. So I thought that was kind of cool. This book was published in 2000. The paper came out, I think, in 1996, 97 timeframe. And then the Java 5 release added support for the executor completion service. So it was a good example of how a pattern finds its way into a very well-established piece of software that's widely used that realizes that pattern. Obviously, when we wrote the book, we couldn't use the executor completion service as a known use because they hadn't developed it yet. But there were other good examples of known uses based on Microsoft abstractions like I/O completion ports and async I/O. Let's quickly show how you can instantiate an instance of the executor completion service. So the executor completion service is a class that implements the completion service interface and uses the executor to execute tasks, which are then placed in a blocking queue when they complete. And here's how you use it. The first thing you do is you go ahead and make yourself some kind of new executor or executor service. So in this case, we go ahead and make ourselves a new fixed pool executor. And we stash that away in some field. And then we create ourselves a new executor completion service object, passing in the executor as a parameter. And so what that does is that will then go ahead and associate this executor with the executor completion service. And then when someone submits tasks to the executor completion service, to this guy here, that then uses the executor service and the pool of threads, in this case a fixed size thread pool, to run that in the background. And of course, what's cool about this is you can change the type of thread pool just by modifying this call. You could have new cache thread pool, new work stealing pool, new single thread pool, or whatever. And that will then be completely shielded from usage of the executor completion service itself. So that's one of the powerful features of using the executor framework in conjunction with the executor completion service. Okay, so that's kind of an overview, give you a big picture view of what this framework is about, what the interface does, and we'll talk about other aspects in just a moment.